In this video, we're going to look at a couple of questions on a simple series circuit. Pause the video now and try both parts of this question. So part 1 asks how much charge flows in 2 minutes. So we've been given charge, current and resistance. So what should hopefully come to mind is charge is current times by time. The current is 9 amps and the time is 2 minutes, but we don't want it in minutes, we want it in seconds. So we have to multiply by 60. So 9 times 2 times 60 gives us our answer, which is 1080 coulombs. Coulombs is the unit of charge. 2a says calculate the power dissipated in the thermistor. So when it says electrical power, the first thing that should come to mind is power is current times potential difference. And we know that potential difference is sort of given to us, but it's maybe not quite as simple as saying that because we don't know how the potential difference is shared. So we need to think, what else can we use? Well, we've been given resistance and we've been given current. So what we can use is the slightly more complicated version. It comes from taking in this other relationship and substituting in the V into this equation. So we end up with power is current times resistance, or you'll often see this as I squared R. So we can now substitute in our values. Power is current squared times resistance. So it's 2 milliamps times by 1,000 ohms. So at this point, there's another trick, and it is worth 3 marks. So, we should realize it's not as simple as just using a simple formula. What is 2 milliamps? 2 milliamps means 2 times 10 to the minus 3 amps, or 2 divided by 1,000 amps, because milli means 1,000th. So it means divide by 1,000. So what this is really is 0.002 amps times by 1,000 ohms, which is 2 watts. So 2 watts is the answer. Part B says, what is the resistance of the fixed resistor in the circuit diagram? Pause the video now and try this question. So again, it's 3 marks, so we should know it's not going to be super simple. There's probably going to be 2 steps to it. So if we could work out the potential difference across this, that would probably help us. Or maybe if we knew what the current was and the potential difference, maybe that would help us. So what do we know? We know that it's 2 milliamps through here, and we know it's 1,000 ohms. So we can use that to work out the potential difference across this resistor. We know that potential difference is current times resistance, which now actually makes me realize I've made a really stupid mistake over here. What did I forget to do over here? I didn't square it. I was supposed to square the current. So I should have done 0.002 squared times 1,000, which is 4 times 10 to the minus 3, or 0.004 watts. That was a very silly mistake that I made, because now here I need to do just 0.002 times by 1,000, which is 2 volts. So we know that V1 here is 2 volts. So if it's 2 volts across here, what is the voltage across here? Well, it must be 5 minus 2, which is 3, because these two must add up to 5. So now the voltage across the resistor, like we said, is 5 minus 2, which is 3 volts. And we know that the current must be the same everywhere because it's a series circuit. There's only one route for the current to flow. So we can say that resistance is V divided by I, which is 3 volts over 0.002 amps. Oops, 3 divided by 0.002 is 1,500 ohms. You might have spotted a slight shortcut. If the potential difference across this one is 2 volts and this is 3 volts, you know the potential difference is 50% more, so the resistance must also be 50% more. 50% more than 1,000 is 1,500. Okay, the final question is part C. Pause the video now and try this question. So this is the thermistor. So what happens when it's cooled? So as it is cooled, its resistance increases, so it receives a greater share of the volts, which means the voltmeter reading increases. So we have to remember that in a series circuit, the greater the resistance, the more potential difference there will be across that component.